Hello everyone. Today we understand what is connection pooling. In real world scenario, our application is hosted on a server, say A, and database is hosted on another server, say B. The server A communicates with the DB server through a driver. For example, if we are using a Java application, then it uses JDBC driver to connect to the database. For Node.js to connect with the Postgres database, it uses a PG module, which is nothing but a driver. This happens at the driver level, at the application level. Next, at network level, we use TCP protocol. If you have seen that video on TCP protocol, then you will know that there is a three-way handshake required to establish a connection, and a four-way teardown is required to close the connection. So this is where the problem arises. Imagine you have a 10,000 users hitting your app server. That may be for say login or a flash sale. So this request after authentication and authorization will go to the database server to fetch the data or to update the data, whatever. So what is happening is when when your server is getting too many connections, there are chances the database might get crash. Okay, in our example, when 1000 users are hitting at the same time, then all these requests will go through the process of creating a TCP connection in order to connect to the DB server, and all this will be happening in the concurrent because all 1000 requests are received at the same time. So there will be a TCP connection creation and closing of this TCP connection when the query execution is completed or cancelled. So this is expensive. So creating a DB connection is expensive. So what solution we have? We can maintain a pool of reusable connection. What it means is, uh, what what does that mean? Is even we receive 1000 requests, we will create a batch or a pool of say 10 requests, and only those 10 requests will be forwarded to the DB server. Once these first 10 are completed or cancelled, next 10 will be allowed. So we will be sending batch requests to the DB. We will not send all the 1000 requests to the DB, which will make sure the DB is not crashed because of multiple requests. The benefit of this is faster performance, limited number of connections, which will make sure that DB is not crashed, and it is highly available, and it also improves the scalability. Now let me show you one demo in Node.js so that it will be easy to understand. So first, this is a Node.js project where I am not using a connection pool. So this is simple. This is a PG driver that is used to connect to Postgres from Node.js. So I have created a simple route. This is a simple get API where I'm just creating connection pool. You should not do this ideally in the API call, because every request you will be creating a connect client object, and then you will be passing that and you will be making the API call, database query call. So this is not recommended, but this is for demo purpose. I'm just showing you. This is the client is getting connected here. This is a simple query we are firing where we are making the PG to sleep for 1 second. This is 1 second. Ideally for production application your query should be executed within 1 second, but for demo purpose I have kept it 1 second. And then this is just the time we are calculating how much time it took for the request to process. Now I'll just, and there is a benchmark in the Node.js where we'll be using Node.js to make an API call. So for here we are hitting 10 requests concurrently. So here request.push, we are pushing all the requests, and using promise.all we are making sure that all requests are hitting concurrent. So here we are first creating 10 requests, same localhost 3000 it will be hitting, and all requests will be fired at the same time, and we will be calculating how much time it took to execute the query. Okay, now first let me run the no connection pool call. So here your server is started. Next I'm just doing a benchmarking. Let me just run that. Started. You see, so what happened is all 10 requests went parallel in concurrent to the DB, and so you got response in say 1 millisecond, 1000 millisecond, and all requests were success. Now using connection pool, we'll do it. First I'll walk you through the code. So the connection pool, the code is same. Here also we are using PG driver. Only change is here we are using a connection pool of max connection. Here 5 connections are allowed. Only 5 connections will be established. So what is this max connection default value? So uh, this updates the default value. So for example, the max connections in Postgres is 100. So if you have app server, so for example, if this app server is, say, you have created a 5 instance of same app server. So 5 server, and you have given which each receiver 10 requests. So then total requests will be 5 into 10, 50, and it is within the maximum connection range which is allowed by Postgres, so it will be allowed. Next, if you spin up say 15 instances of your app server and each of them receive 10 requests, so 150 15 into 10 is 150. So this is which is out of the connection range of Postgres, so it will throw too many connection errors. So this is important to understand. So you have to make sure this max count is within the range of your Postgres configuration. If you want, you can first check what is your Postgres configuration, and then you can update this. So default value is 10. I have kept it 5, and the code base is same. I'm using the same query. We get API, same call. Only change is instead of connecting through a client, we are communicating it through a poll. Poll is nothing but an object that we are using, mentioning how many connection pools we need. Same query, 1 second, and that's it. So I'll just run this part where I'll be using now connection pool. Started, and I'll be hitting the benchmark query now. So you see, you're using 5 requests in parallel. Yeah, so first it went, you see, first 5 requests gone. After those were completed, next 5 requests were been sent, and then the connection got closed. So this is how total second record 2,000 milliseconds. So now you will say, although you were when at the first time when there was no connection pool, you were all the 10 queries were processed in 1 millisecond, and the same request with 10 queries, but they were processed in 2000 milliseconds. So then what is the advantage of using connection pool? So this is for demo purpose I have kept, and everything is on the single machine, so I have kept it on a very low number. So when it goes to the server, generally these numbers are very high. For example, here you will not get 10 requests, you might get 1000 requests. In that case, it is very important to handle all those requests. None of the requests should get failed. All the requests should be processed with 200 or 400 errors, so 400 error codes only. So for that we are using connection pool in order to make sure that all the requests are processed. So in one more thing to note here is connection pool, what happens is it creates a TCP connection. So I have created a connection pool of 5. So 5 TCP connections will be kept open every time. There will be no TCP connection creating every time when a request is received. So for example, if say 6 requests are received and we have 5 TCP connections allowed, so first 5 will be first processed and 6 will be kept waiting unless any one of the connection is free from the top 5. So and the wait time is around milliseconds only. We are talking about waiting time only millisecond. It's not more than second. If it's more than second, then it's a problem with the query. You have to check with the query why it is taking more number of time. And also in pool there is option of a timeout. Currently where from the app server you can pass a timeout, where after that particular timeout the connection will be the query will be closed, and that connection will be available for the next request. So that option is available in this driver. So you no need to worry about, like, suppose if my query is long running, you can give a timeout in the application also, and also there is a timeout at the database level also. I'll just show you that. So this is the query to get the timeouts that you have been set as a default setting in PG. So here you can see this idle session timeout. set the maximum allowed idle time between the queries when not in transactions. For example, if you are firing any one query, and then if you want that, okay, after 1 second, if there is no date, if there is no response or the query is not completed, you can cancel that query, so that TCP connection is available for the next query. So you can use this, you can directly do this setting in the Postgres level, or you can send that parameter in the application level also. Here you can see you also have a TCP user timeout, where you can actually give a timeout to the TCP connection. So currently these are all set to 0. That means there is no timeout defined. You can change it. You can either change it at the Postgres level, or you can change it through the application level. For this TCP user connection, I'm not sure if there is an option available at the app level. You'll have to check in the Node.js or in the Java whether there is option available. But yes, for idle session timeout, this option is available. The key name is different. For Postgres, it is connection timeout, connection session timeout. You can use that. So yeah, so in summary, collection pool allows you thousands of users only with a few database connections, making sure that the database is always available. Yeah, thank you.